So in that last module, we kind of introduced this kind of modeling technique of interactions, where we kind of we create a new variable, which are two kind of continuous variables that were multiplied together. And so the marginal or the marginal effects of one variable depend on the level of another, or the partial effect of one variable depends on the level of the other variable. Now we're going to talk about interactions again, but now the kind of interactions we could see, there's kind of two more interactions that we could see. So let's just maybe list them all. So we could have, so remember, interactions are just variables multiplied by each other. We could have two continuous variables multiplied by each other, and we saw this before. That was in that last module we talked about interactions. The next kind of, now that we've kind of talked about or introduced this new kind of variable, this binary variable, we could have a dummy variable or binary variable times a dummy variable. So that's something new. And the third one is that we could have is a dummy variable times a continuous variable. So these second two are situations we haven't seen before. And so consequences, so let's talk about what these would do. Well, multiplying two dummy variables by each other, they're not continuous, they're just dummies, 1 or 0. So when they're both 1, what it's going to do is it's going to change the intercept for certain groups. So 2 is going to change the intercept for certain groups. So groups where this new dummy variable equals 1, so if both of these equaled 1, then the interaction together equals 1, and so you're going to have a different intercept for those people. And the consequence of 3, how the language people usually use is different slopes for different folks. So it's going to change the slope of this regression function for certain groups, which might be a really useful modeling technique in a lot of situations. So let's quickly erase this and we'll kind of give an example of each of these. So let's think about an example where there's an interaction between dummy variables or binary variables. So a dummy times a dummy, or a binary variable times a binary variable. So let's say we have our first binary variable is female, and that equals 0 if they don't identify as female, and 1 if they do. Let's say we have another one, which is male, which is 0 if they don't identify as male, and 1 if they identify as male. Let's assume that you have to be one of these two categories. Let's just assume. And let's say we have another category, another dummy variable, which is married, which is 0 if you're married, if you're not married, and 1 if you are married. And so we can think about running a regression. Maybe we have education in there again. Let's just have one continuous variable, so it's going to be a nice diagram, or the diagram won't be too bad. So let's say I have a first dummy variable, and let's have female. So this is a dummy variable, 1 if you identify as female, 0 if not. Let's have another one which is married. So this is 1 if you're married, 0 if you're not. We're going to have a third one, which is married times female. And so here's this interaction between two dummy variables, married times female. Then we could have another one, maybe, which is married times male. And so these two variables, this is an interaction. And so before we go any further, the reference group, assuming that people either identify as male or identify as female, if they have to identify as one of the two in our data set, would be non-married, individuals who identify as male. Right? To think about our reference group, we need to think about which group we're leaving out, and having all of these kind of effects shut down. So they can't be married, because then this effect would show up, and they can't be female, because this effect would show up. So they're non-female, non-married. This variable equals 0, this variable equals 0, this variable equals 0, and this one equals 0. So the intercept for that reference group is just beta 0. Whereas everyone else is going to have a different intercept based on which group they're part of. So all this is going to do is kind of change, going to have us have more intercepts. So the slope for all these individuals is going to be the same. It's going to be beta 1 because we only have this one continuous variable. But maybe this first line is beta 0. The slope is beta 1. And we have, maybe delta 0 is negative. So the intercept's a bit lower for someone who's a non-married female. So think of this as non-married female. This is non-married male, just assuming you have to identify as one of the two. The slopes are the same. And we're going to have, I don't know if these colors are even showing up here, but we're going to have a couple more. Let's say this is the regression line. It's going to have the same slope. Let's say beta or delta 2 is negative, which means, if you're married and female, these are both going to equal 1. And so this is going to be part of your intercept. So that's assuming that, again, delta 2 is now negative, and this would be the regression line for someone who identifies as female and is married. And then, I'm running out of colors here, but hopefully this pink one will work. Let's say this last one is positive. This delta 3 is positive. The intercept is beta 0 plus delta 3. So for someone who's a married male, this is going to be 1. This is going to be 1. And then everything else is going to be 0. So they have beta 0 and delta 3 as their intercept. So this is going to be for married males. So notice that this is just adding more kind of categories as we have these interactions. It's kind of just changing the intercept for certain groups. It's not changing, all the slopes are the same here. We just have one slope, one continuous variable, and all we're doing is having more intercepts because we're having more categories. And again, the interpretation of each of these betas and deltas has to do with the reference group. So again, this delta 3 is capturing the difference in wages, the average difference in wages between a married male and a non-married male holding education constant, for instance. So again, the interpretations depend on the reference group. And so we need to make sure we understand how to come up with the reference group, which is what's going to hold if all these dummy variables are equal to 0. So now let's look at an example where we have an interaction which is a continuous variable times a dummy variable. All right, so let's look at an example. So let's say we have wage again. Beta 0 plus beta 1 education. So there's a continuous variable. Let's say We've been using deltas for this, so let's erase that and use a delta. Delta 0, and again, let's use female maybe. And then let's have this beta 2, which is going to be education times female plus u. Here's this interaction. So education's a continuous variable. It takes on different values, or we can think of it as a continuous variable for the sake of this question. But female is a binary. You either identify as female and equals 1, or you don't equals 0. And again, kind of what I alluded to before is it's different slopes for different folks. So let's think about, for people who identify as female, let's think about the change in wage from a change in education. So if you identify as female, that means, again, let me try to get a different color here. This equals 1, and this equals 1. And the returns to education are going to be beta 1, so taking the derivative of this with respect to education, beta 1 plus beta 2. And if female equals 0, the returns to education, or the partial effects of education holding, well, I guess it's the only variable here, so we're good, is just equal to beta 1. And the intercepts here are different as well, right? If someone identifies as female, their intercept's beta 0 plus delta 0. If someone doesn't identify as female, then their intercept is just beta 0. So let's think about what that means visually for a regression. So let's just draw the regression line for someone who doesn't identify as female. So if they don't identify as female, use a different color. Let's use pink. That means this variable is 0. This variable is 0 if they don't identify as female. So that drops out and that drops out, which means beta 0, well, there's fine. Beta 0 is the intercept. And as we saw over here, beta 1 is the slope. Now let's say, we're going to have to make assumptions. We're going to say that delta 0 is, again, let's just say it's less than 0, but let's say beta 2 is greater than 0. So the intercept, if someone identifies as female, the intercept is delta 0 plus beta 0. So delta 0 is negative, then the intercept for someone who identifies as female is going to be below the regression line for someone who doesn't identify as female. But now if beta 2 is greater than 0, that means the slope, the returns to education, are higher. And so this slope here is beta 1 plus beta 2. Now if beta 2 is less than 0, these lines would be getting further apart as we went over. And so kind of what these graphs look like is going to depend on the sign and the sign of these deltas and a beta 2 and these interactions here. But let's say it looked like this, where delta 0 is less than 0 and beta 2 is greater than 0. Well, if that's true, what that's saying is that someone who identifies as female maybe starts out with lower wages, but if they get a certain amount of education, their returns to education are higher. I should say the returns to education are always higher. But if they get a certain level of education, all of a sudden their wages would be higher than someone who doesn't identify as female. So we could figure out where they crossed as well. You know how to do that mathematically. You can find out where these two lines are equal. Then any education level above that, this orange line would be above the pink one. But in general, like the shape of these lines is going to depend on kind of the signs of these, this coefficient on the female to figure out the intercept, and then this slope parameter. If this beta 2 is less than 0, they get further apart. If it's greater than 0, then returns to education for someone who identifies as female is greater than male. But that's kind of how these continuous variables that are interacted with dummy variables work. They kind of change the slope for different groups. So here the returns to education for someone who identifies as female is different than someone who doesn't identify as female.